In this video, I explain the detection of multicollinearity. In this video, we learn one method to detect the multicollinearity. The name of this method is R-square, to check the value of R-square, which is also called coefficient of determination. If R-square is high among the regressor, greater than 0.8, the value of R-square is very high among the regressor. It means it leads to that there is the presence of multicollinearity among the regressors x1 and x2. We also check f-test and t-test to check the reliability of the model. But in the presence of multicollinearity, these two tests contradict with each other. So we look with the help of this example. This is the regression model. Y is equal to alpha plus beta 1 x1 beta 2 x2 plus the error term. These two are the regressor x1 and x2. If R square is very high, means these two variables have strong collinearity among each other. So f-test in most cases which will reject the hypothesis that partial slope coefficient. So here is question, what is partial slope coefficient? Partial slope coefficient means we check the effect of x1, means independent variable, first regressor, on the dependent variable y, assuming x2 is constant. Then this beta 1 is the partial slope coefficient. In the similar fashion, we want to check the effect of second regressor x2 on y, assuming x1 is constant. Then beta 2 is the partial slope coefficient. So this is the partial slope coefficient. So f-test in most cases reject the hypothesis that partial slope coefficient is 0. So we have two hypotheses: null hypothesis, partial coefficient is equal to 0, and alternative hypothesis h1, partial slope coefficient not equal to 0. So f-test reject this, h0 beta is equal to 0, reject this hypothesis, null hypothesis. But on the other hand, t-test, as you know, in the presence of multicollinearity, standard error is high. So high value of standard error, we discussed this point in the my video in the practical consequences of multicollinearity, that is available on my channel Statisticians Club, and I also provide its link at the end screen. So t is equal to beta. Beta is the partial slope coefficient under consideration, and standard error of that variable, standard error of beta cap. When this value is high, and then t ratio is very small in the presence of large standard error, t ratio is small. So this small value mostly leads to accept h0. The individual t-test will show that none or very few partial slope coefficient are statistically different from 0. Mostly partial slope coefficient leads this assumption that h0 is equal to beta is equal to 0. Little bit follow the h1. So these two tests contradict with each other. F-test leads to reject this, and t-test leads to accept this, and high R-square among the regressors, which is the presence of multicollinearity. So these are the signs to check the model. There is the strong multicollinearity and it has bad effect on the model. If you like video, then click on like button and subscribe my channel Statisticians Club. I regularly upload videos on econometrics and multicollinearity. I also have a playlist in the name of multicollinearity where you can find all topics and lectures on multicollinearity. Thanks for watching.